Good, my dear students. Okay, in module 1 you are having three different types of numerical problems. Okay, so that is problems on minimum potential energy, problems on Rayleigh method, and problems on Gallican method. Okay, so already we studied about the problems on minimum potential energy. So this is in this video I'm going to tell you about how to solve the Rayleigh method problem. Okay, so this is most important question. So in examination definitely they may ask you one question from. Okay, so all these three methods, that minimum potential energy, Rayleigh method, and Gallican methods, are used to find the deflection stresses of the given problem. Okay, so the main purpose of these are for solving these means you should know the deflection, okay, at the midpoint, at the center, or at the last. Okay, so that is the main purpose you are going to use this, and all these are analytical method only. That is, you are going to get the approximation solution. Okay, so here we are going to solve the first problem. Okay, so before solving the Rayleigh method, let me understand you. So what do you mean by Rayleigh method first? Okay, so Rayleigh is nothing but what? So it is a integral approach method, so useful for solving the structural mechanics problem, and it is also known as variational approach. Okay, so this is definition. You have to, the definition they may ask you in the examination, but you have to remember. Okay, so problems on Rayleigh method, it is also called as, shortly it is called as RR method. Okay, RR method nothing but what? It is a Rayleigh method only. Okay, so before solving the Rayleigh method, let me understand what are the basic steps involved in, that is to solve the RRH method. Okay, how to solve? Okay, let me understand now this procedure, how we are going to solve. Okay, so normally Rayleigh method is what? It is an analytical method to determine the approximate solution for the given problem. Okay, so it is an analytical method to determine the approximate solution. Okay, so how to solve, what is the procedure for solving the Rayleigh method means you have to use these 5 steps. Okay, that is formulation of potential energy function for a given body, that is you have to calculate the total strain energy of the given problem and total work potential. Okay, I already told you strain energy nothing but what? The internal strain energy, work potential, it is due to the external force. Okay, so next, second step is assume the trial displacement function for a given problem, that is the function should be satisfied the boundary condition. We are going to use two polynomial displacement function, that is polynomial function and trigonometric function. Okay, we are going to use only the polynomial function many times. Okay, so step number 3 is after calculating the polynomial function, substitute the displacement function into a potential and into a potential energy function. Okay, all those values you have to substitute in this equation. Okay, so then how many unknowns are there? You have to differentiate, that is minimize the potential function so as to obtain the equilibrium equation. Okay, then you are going to get the unknown displacement, stress, strain. Okay, so these 5 steps you have to remember while solving the problem. Okay, before solving this, we have the 6 different types of Rayleigh method, that is the beams. Okay, so this formula have to remember. Okay, for UDL, okay, types of load or beam. Okay, in the given question, simply supported beam with UDL means you have to remember this formula, that is strain energy is equal to EI by T integration of 0 to L d square U by dx square whole square dx. Work potential for this is 0 to L, load, that is P into Y into dx. Okay, P is load, Y is deflection. Okay, this is for simply supported beam with UDL load. Point load is means use this formula, that is strain energy is equal to EI by 2 integration of 0 to L d square Y by dx square whole square dx, and work potential is equal to load into maximum deflection for point load. Okay, so again both that is UDL and point load means use this formula. Okay, strain energy is equal to EI by 2 0 to L d square Y by dx square whole square dx, and work potential for this both UDL and point load is 0 to L, that is weight into Y dx plus load into Y, that is maximum deflection. Okay, so our cantilever beam use this formula, strain energy is equal to AE by 2 0 to L dou U by dou x whole square dx, and work potential is equal to 0 to L P into dx. Okay, and next, bar subjected to point load means we have to use this formula, that is strain energy is equal to AE by 2 0 to L dou U by dou x whole square into dx, and work potential is equal to minus of load into U1. Minus indicate that here the work done by the external force, that is on by the external force. Okay, so many nodes means you just use the integration here 0 to L, that is minus of 0 to L PU into dx. Okay, these 6 formula you have to remember to solve the Rayleigh method. Okay, and apply these steps, basic steps. Okay, then you are going to get the deflection stresses same. Okay, if you solve one problem means you are going to understand better. Okay, so let me understand first problem. Okay, look at this diagram. This is a bar subjected to point load. What is the formula for bar subjected to point load? This formula I have to use in this given problem. Okay, question, I will read the question. Okay, they will give like this. Problem number 1, that is Rayleigh method by RR method. RR method nothing but what? It is a Rayleigh method. Okay, by using RR method, for a bar cross section area A and elastic modulus E and subject to uniaxial load P, show that at a distance x from the fixed end, that is u is equal to P by AEX, okay, and hence determine the end deflection and the stress to which the bar is subject to an axial load. Okay, so you have to calculate the stresses, strain, that is the deflection of the given bar, okay, by using RR method. What is the procedure for using the RR method? You have to identify the which bar is given, okay, then remember the formulas, apply the procedure, you are going to get the deflection stresses. Okay, so this is a bar subjected to axial load. One end is fixed, another end is load is acting. Okay, so AA is given, okay, that is the A nothing but area, E nothing but the Young modulus, the displacement at U stand for U1 and total length is given. Okay, so at displacement at fixed position is equal to 0 here. Okay, A nothing but area of this bar, Young modulus, displacement at point U1 after applying the load. Okay, total length is L. Okay, so this is about the given diagram explanation. Okay, so what is the step procedure for the bar given subject to axial load? Means we have to use this formula. Okay, that is this. Let U be the axial displacement at any point x from the fixed end when the bar subject to uniaxial loading P at the point 1. Let U be the displacement at load number point number 1. Okay, that means what here? So if we put axial load at node number 1, U1 be the displacement at point 1. Let us assume that U is equal to U1. Okay, so first step number 1 is formulate the potential energy function. So potential energy function is equal to what? Formula is equal to pi is equal to strain energy plus work potential. Okay, so where strain energy is the stored bar in the given energy, stored energy in the given bar, so which is given by strain energy is equal to AE by 2 integration of 0 to L dou U by dou x whole square dx. So this is already there in the list of formula I mentioned in the, okay, so work potential is equal to what? Work potential is equal to minus P by U1. Okay, so minus indicate here work done by the system, consider as negative sign. Okay, so substitute these two equation in equation number, this equation potential energy function equation, that is pi is equal to substitute here AE by 2 integration of 0 to L dou U by dou x square dx plus here minus is there, so minus P into U1. Okay, so substitute in this equation strain energy and work potential in the above equation, you are going to get the potential energy equation, that is form potential energy equation. Okay, that equation number you give equation number 1. Okay, how we know these two equation? It is already there in the list of formula, that is procedure. Remember, for the bar subject to axial load, you have to note down here and substitute this formula in the potential energy function. You are going to get what? Pi is equal to AE by 2 integration of 0 to L dou U by dou x whole square dx minus P into U1. Okay, so give equation number 1. Second is what? Assume that polynomial displacement function. So here this is, look at, this is very important step, second step. Okay, so this is a second order, so assume polynomial function is equal to what? U is equal to A0 plus A1x for second order element. Okay, this is 1 and this is 2. Okay, so now apply the boundary condition. Okay, where A0 and A1 are the generalized coordinate to be determined from the boundary condition, that is x is equal to 0 and U is equal to 0. From the equation, that polynomial function will become what? U is equal to A1x and U is equal to, at x is equal to L, at x is equal to 0, U is equal to 0, you are going to get A0 is equal to 0 value. Okay, at the same time, at the second condition, that x is equal to 0 and x is equal to L, so you are going to get what? U is equal to U1. Okay, this is from equation number 2. Okay, so from equation number 3, so at x is equal to L, U1 is equal to A1L. Okay, so these you need to calculate the A0 and A1 value. Okay, so here A1 value is equal to what? L by U1. Okay, so you have to calculate these by substituting these boundary condition. Okay, I will repeat again. At x is equal to 0, U is equal to 0, A0 is equal to 0. So after substituting the equation number 1, that is polynomial function. Okay, therefore the equation 2 becomes U is equal to A1 x1, give equation number 3. Again at x is equal to L, substitute U is equal to U1. Okay, U is equal to U1, x is equal to N, you are going to get from equation number 3 U1 is equal to A1L, give equation number 4. Okay, differentiate with respect to this, with respect to what? X. Okay, because here dou U, we need to calculate dou U by dou x value. Okay, then you have to differentiate. Okay, so if you differentiate with respect to x, we are going to get what? Dou U by dou x, x differentiation is 1, therefore A1, give equation number 5. Okay, equation number this you have to differentiate. Okay, next third one is substitute the displacement function into potential energy function. Okay, from equation 4, 5, substitute in the equation number 1, that is pi is equal to AE by L, 0 to L, substitute this dou U by dou x value here. Okay, so we got A1 square dx minus P1. Okay, again you simplify this AE by 2 integration of, you have to apply integration here, you are going to get A1 square is a constant, x0 0 to L minus P A1 L. Okay, again you have to resimplify this, pi is equal to AE by 2 A square L minus P A1 L. Okay, so this is a minimum potential energy after substituting the displacement function. Okay, give equation number 6. Okay, to minimize the potential energy function, what is unknown here? A1 is there, so differentiate with respect to this, which is equal to 0. That is a condition for minimum energy potential. Okay, the condition for minimization is dou pi by dou A1 is equal to 0. Suppose here A2 means, again you have to differentiate one more quantity. Okay, so dou pi by dou A1 is equal to 0. From equation 6 we have pi is equal to ae by 2. This is a constant term. A1 is also constant term minus, that is a1 square l minus pa1 l1. Okay, so I differentiate this equation with respect to a1, that is ae by ae. Okay, this what ae to this 2 to going to get cancelled. You are going to get la1 minus pl, which is equal to 0. From this equation this goes that direction, which will become 0, that is a1 is equal to p by ae. So we got the a1 value. Okay, so what is the last step? Determine the displacement, strain and stress to find the, okay, to find this. Okay, the substituting the value a1 equation, this a1 value you have to substitute in the equation number 3. You are going to get u is equal to p ae by x. Okay, equation number 7. So hence we are going to get the displacement at middle. Okay, to end the deflection of the stresses, okay, I substitute at x is equal to l. Okay, this is the middle one. Okay, at x is equal to l, at the end is equal to, at x is equal to, if you substitute, you are going to get u is equal to p is equal to ae. Okay, so this is what you are going to get the answer. Okay, so therefore the equation we have u is equal to p by ae into x. Okay, but strain is equal to what? Change in deformation, dou u by dou x, which is equal to p by ae. Okay, according to the Hooke's law, you are going to get stress is equal to strain into Young modulus. Okay, so stress is equal to this formula, we already get strain formula. Substitute strain is equal to p by ae here. So finally you are going to get stress is equal to load per unit area. So hence we are going to prove this given problem, that is deflection. Okay, so like that you have to remember the formulas. The main thing to determine the using Rayleigh-Ridge method, you have to remember the 6 formulas and procedure, apply, you are going to get the stress strain deflection. Okay, so like this you have to solve the numerical problems on Rayleigh-Ridge method. Okay, so here I am going to use the textbook, the images textbook, that is the problem textbook by SB Halesh. Okay, so I am referred by SB Halesh. Okay, so that the images I copy paste here, then I explain. Okay, so this is what I am going to tell you. Okay, so I hope you understand this Rayleigh-Ridge method. Okay, now will in the next class we will move on to the another problem. Okay, thank you.